Good morning. So I want to continue. This is page 82. Here, the area, about area. Okay. So then you can, this thing is easy to remember, I think. Okay. This dA is epsilon ijk dxi dxj. Am I correct? I'm sorry. This is like here. There's a two vectors. So we need two vectors, dx and two vectors. There's a dx, and another was dx star. Okay, so then there is a dx. Okay, so this is easy to remember. Okay, then there is also some formula which is easy to remember. dxi is partial xi partial x alpha dx alpha. So this is in abbreviated form. This is written like partial alpha xi. Yeah. So then dxj star is the same. You can have abbreviated form. Partial. No. Here dx alpha. Partial beta xj star dx beta. So you put this in here and here. Yeah. Then finally you obtain. You have epsilon ijk, yeah, partial alpha xi partial beta xj star, then dx alpha dx beta. This is what you have. Okay, then how do you change this thing to this? The question is, let me see. Let me see, how do you change? So there is a hint here. So we use 137. You have to use 137. This is a kind of, I would say, strange. See, I would put this thing. Anyway, okay, let's just use this. Epsilon. This one is. So we have epsilon. Let me change color. Epsilon ijk alpha I beta j. No, sorry, we don't use this. Let's change. beta j alpha alpha. I think everything looked okay first. Okay. Funny thing here is the star is dropped. Okay. Here I don't need a star. This is ridiculous. We don't need a star here. We just need a star here. So we have a star here, but we don't have a star. So then this makes sense. Okay. So then 132. We have 132, 137. Total weight 137 here. IJK beta j gamma k. JK. Let me just follow this notation, JK. We use don't like this sound. Let me see. Let me try this. This one alpha. This one beta. This one gamma. This is alpha. This is beta. This is gamma. How do you change this? Alpha, beta. Okay, I think this has to be JK. Sorry, here from the beginning, this has to be JK. But this is AI. So this is a JK. Right? So this is a J and K. Okay, so we have JK is okay. We just change beta to alpha, gamma to beta, alpha to gamma, beta to alpha, gamma to beta, alpha to gamma. This is fine. IJK alpha J beta K. ijk alpha j beta k. Okay, so this whole thing, this thing now is epsilon gamma alpha beta is epsilon gamma alpha beta j I j partial I x gamma. But before that, actually this one, you can see, let me change this one, epsilon gamma alpha beta, and this one, x beta. Okay, this combination is dA, unfortunately gamma is dA gamma. Why is this gamma? See, this is like, we can just follow this one. We just do beta gamma. Here we just use, instead of alpha, we use beta. Then here we use, instead of beta, we use gamma. So then we have, instead of alpha beta, we have beta gamma. Then we just apply this equation. Beta j gamma k. Beta j gamma k become epsilon alpha beta gamma. Here is alpha beta gamma j partial I x alpha. So now here this is alpha. Okay, then we combine. So here also we have beta and gamma. So if we combine this thing, we obtain A alpha. So then the remaining thing is this one. This is something remaining. And then we have this dA. So we put this one combined. So we have J dA alpha partial IX alpha. So we got this. Yeah. So then we take derivative. This is the derivative of product. Yeah. So then the constant term we put aside, outside. So we take derivative of j, and the remaining thing is partial I x alpha, plus we have j ddt partial I x alpha. Okay, so then dj dt, I don't I don't know if I remember dj dt. What is dj dt? Do I have dj dt? dj dt? I think we did it very recently. dj dt here. Okay, here because j is a function of 9 parameters. This is the, for example, partial 1 x1, partial 1 x2, partial 1 x3, partial 2 x1, blah blah blah. 9 parameters. Right? So we take each one, we take each of these as a parameter. So partial derivative of this, then time derivative of this, then this part is here. This there was a formula, right? I don't remember this. Is this strange partial? How do you understand this? I forgot. Vi to partial alpha xj. How do you do this? I think this we have done this first time. This is what we did. Partial alpha is like partial x alpha. This is like partial xj, partial xj, partial x alpha, right? So we have vi here. So wij, we have this, then we have this. Okay, so let me see. Hmm? So here we have this same thing. We have partial x. We have partial small x I, partial small x I, partial large x alpha. Then you have xj. I think we first take derivative on j, so you will get vi. So xj is changed to vi. So actually it is very hard to understand the difference. D dt, there's something partial t, then also d dt. So I don't know exact difference. We try to figure out maybe later, okay, but then we have Vj here, so we have Vj. So we have Vj, it's crazy, huh? Because here, here we have this equation, right? So this is xi go to vi, and vi remain here. So we have same thing. Alpha j. Okay, here it is xj. This is typo. Is it typo? Yes, something, right? We have this one. xi go become bi. So then this way. So same equation. Alpha I, alpha vi. This is just the same page or no? Vj, vi alpha j. Yeah, this is same. Then what is the thing? What was the confusion? I think we have solved this confusion. What is the problem? ddt d alpha. Okay, anyway, I think I solved this part. Then I think we have been working on djdt. I think we have been working on djdt. So let me do this. Yeah, djdt goes like this. And I'm not quite sure. I think this is okay because you have some function like this f g t, right? Then if you want to take a derivative of this, then you can do this partial f partial g, then you take dg dt, right? So it's same type. You can do this. But then the funny thing is this shouldn't be j. This is I. Then I think it makes clear. So partial alpha xi is ji alpha j. Ji alpha j. So I think it's same. Ji alpha j. Yeah. Okay. So this just this mistake. So you have this. So this part is like this. Partial j, partial I, alpha xi, alpha xi, then partial j, partial alpha, partial xy, d dt, and this final part become this alpha j jvi times alpha j jvi. Am I correct? Oh my god. Then there was an equation to change. It was alpha this one, right? Partial I, partial I xi, x alpha, and j is a j. See, you can see it's not d alpha. This is dA. See, this is dA. Partial I x alpha j. Large x alpha j. Partial I large x alpha. Okay, here. This and this combine. Then we have 1 over j dA I. This is dA I. So we have like 1 over j. If I put this 1 over j there, then how do you get I thought I figured it out. DJDT. There was some section explaining DJDT. I think there was some part. This is the thing. But there is no J. Oh, there is something. I think I screwed. DJDT is J partial I X alpha. Alpha I. So this is J partial I X alpha. This thing. Then we can cancel J. So what we have is this. See, we want this one. See, we see this combination. This combination is partial small xi large small xi. Upstairs we have large x alpha. Then we have partial small xj large x alpha. See delta ij. Yeah. So delta ij change j to I or I to j. So let me change I to j. So then we have this partial final thing is this. Finally we have this one. So this is the first term. Second term. We also have to consider second term. Second term, how do we get? I think we first convert. Let me see. Let me do it again. We first convert this one. I think there was page. I think there was page. I forgot. No. Partial I x. Let me see. Go to this page. This one, right? This thing, I alpha, I alpha, I alpha minus ij j alpha. This one is minus I j j alpha. Oh my god. I j j alpha partial v partial x partial v partial x, right? So then this thing, yeah. So if you have this one, this thing times this thing. Okay, this combination gave d small j, and that's it. No, I'm sorry. We have to d okay, ddt partial I x alpha ddt this one, including this. This is this. Okay, so we have finally this. Yeah, partial I vi vj and d a aj. Okay, so let me see the time. And we have this material derivative and of integral. We come across different types of integral quantities in continuum mechanics. And it is important to know how to calculate the rate of change of these integrals. Line integrals. Let C0 be a material curve at t equals 0 and C be its deformed shape at time t. The material derivative of the line integral of phi, which is a component of a tensor-valued function, tensor-valued function, component of tensor-valued function, very complicated, which is a component of tensor-valued function. Anyway, so we have some line integral, then we take time derivative of this line integral. So first we convert this dx to this. This is the usual deformation we take. So then we make time derivative of this. Time derivative of this. So we first take derivative of this part. Then we take derivative of this part. This part will become this. It's hard to remember the formula, right? This one. Time derivative. We have this. Here. Alpha I, Ji alpha J. Ji alpha J. Ji alpha J. Partial V, partial X. Partial V, partial X. Alpha XJ. Alpha XI. Alpha XI. Okay, it is okay. So I think this is okay. Then we recombine, put it back. This thing and this thing. Does it make sense? If you have partial xi, partial alpha x alpha, d x alpha. This is just a d x alpha. And same here. Partial, this thing is partial xj, partial x alpha, dx alpha. So this is partial dxj. Yeah, I think it makes sense. If C is a fixed curve in space, so this part I didn't understand. This is a fixed curve in space. Because this C it's deformed. CB it's deformed shape at T. So I don't know if this does this mean C doesn't deform? I don't understand. See, then here ddt goes to small ddt. So I'm sorry, this part I don't understand. Aerial integral. Aerial integral is also similar. For material surface S, using the transformation to the undeformed system, for a material surface S using the transformation to the undeformed system, we get the material derivative of the time of the area integral of phi very okay, so area integral of phi how do we get this? I think we have to do the same procedure as above. Yeah, because we should have area. Do we use this one? I think do we use this one, right? See this part. This part is more like this. ddt dai. So this part is ddt, sorry, ddt dai. I mean this one. JJDA, IJDA, DJ, JJDA, JJI, IJJ, JJI, IJJ, JJI, IJJ, sorry, JJI, IJJ, JJI, IJJ, partial VDA, partial VDA, partial VDA, partial VDA. So we use this one. We use this one. Then we have to combine back. See, then we use D. This one, right? DDT I alpha. Hmm? I got confused. What is? This is finished, right? What did I say? I got completely confused. whose d phi dt dAi I don't see any problem. What was the problem? I am deriving this one, right? dj dt. I think then there was dj dt somewhere. No, dj dt. I think we did it somewhere. dj dt. Was it one? This is not dj dt. So we should have dj dt in this chapter. Here. dj dt goes like this. J partial I vi. This goes like this. J partial J vi. Yeah. Partial I vi. J partial I vi. J. So we can do partial J partial J. Then we have this. Alpha I alpha. This I alpha. IJJ alpha. This one. this one is I, J, J, alpha, right? So then partial V, partial X, partial V, partial large X. Then you have minus sign. And then, let me see. P alpha. Then there was a aerial change, length aerial. I X alpha D A alpha J. So here I can do this. J, this, this. You have D A I. J, partial J X alpha. So this gives D A J. So you have partial J V J D A I, partial I V J D A J. So we can use this formula here. Finally here. So we obtain this. Then I don't understand this part. Surface S is fixed in space. I'm not sure what this means. And volume integral. This one we also do this. This thing should come from d dt dV. We have done this. Area, volume. Do I have volume? See here. Partial IVI dV. Partial IVI dV. Then I'm not completely sure how you obtain from here to here. May get hint from above. I'm sorry. I don't know what to do, how to do. So let me stop this video here. Then I will try to explain